Hello, everyone, and welcome back. Or well, I should say welcome. This is the first video I'm doing for you guys. And now, this video is to finish up on what we started in class for CAD and CAM EME 508, and specifically recorded for 500 level mechanical engineering students at Joseph Sarwuan Tarka University. Now in class, we started creating these models. And just to explain, my cursor is highlighted with a lime, I don't know whether to call that lime green or lemon green, but that kind of green you see. When I left click, the color is that pink, right? So you are able to know when I left click. Okay. When I right click, the color is yellow, so you can follow to know what I'm doing on my mouse, right? So we drew the pin for this wheel assembly, the pin, the bushing, and the wheel in the last class. For the purposes of this video, I will start again, right? It will be more beneficial. Now, three things I'm targeting. One is to take you through the process of creating three-dimensional models using Autodesk Inventor, and we have 5 of them to walk through. In your exams, you have 1 or 2 models, and you'll be required to describe the process of creating that model in or using Autodesk Inventor. So it's of great importance that you pay attention to this video. Now, I will not be editing this video and such, so you might hear a bit of noise here and there. Of course, there might be a few things that usually I would edit out, but because of my time frame and the time to your exams, I will not be doing that. So bear with all of that, right? So we will draw or create each of these models. Then we would create the working drawings of each of them. So you see what it is or what it feels like doing that. You learn the process, and then we will assemble them together as well, and possibly also create a drawing of the assembled wheel. We will not in this video create the presentation of it, okay, for want of time. And so just pay attention. I will try to be very, very quick. The advantage is it's a video, so you can always go back and forth, okay, depending on what you need to re-listen or re-watch. Great. So let's go to OBS now. Let's go to Autodesk Inventor. To start a new file, so I'm going to start with the pin. And now do remember that every three-dimensional model we do in Inventor is the workflow process is that we create 2D profiles, and then out of those 2D profiles, we now generate a 3D model, okay? And the tools that are available for that, we have Extrude, right, which you've already been introduced to in class. Then there is Revolve, and then there is Sweep, there is Loft, there's Coil, right, and a few others that take a 2D profile, and then depending on its action, it creates a volume, okay, either by sweeping that through a distance or sweeping it along a path or revolving it about an axis and all of that to create a volume out of it, a three-dimensional object. Now, for this exercise, we will be using 3 major 3D creation tools in Inventor: the Extrude tool, the Revolve tool, and the Loft tool. Those are the 3 we would use. So pay attention as we go. So we're going to start with this pin. First off, the pin has 4 or 5 major features. It has a dome, okay? So when you look at the dimensions, it says 22 spherical R, okay? So that thing is a sphere, okay, with radius 22 millimeters. Is that okay? Now, but it is cut by a circle of diameter 40 millimeters. So it sits on a base circle with diameter 40 millimeters. So do take note of that. That's the first feature. The second feature is this cylinder here that has a diameter 20 and a height of 27. And then you have this third feature here, which is a cylinder, also diameter 12, height 33. And then it has a hole. You can see that hole that goes all the way through, which is meant to align with this hole that is here, and into which the number 2 taper pin, which is 38 millimeters long, will go through. All right. So that hole is the fourth feature. And then there is a chamfer, which is the fifth feature of the pin, which is a 1.5 millimeter chamfer with an angle of 45 degrees. So we will draw this first. Okay. Now, because of our time, I'm going to be doing things very, very quickly. So I'm going to select a plane where my cursor is, and there I will draw the circles both for this cylinder or shaft and this one as well, so that when I come to extrude, I can extrude in both directions in one go. Okay, so the dimensions I need are 20 millimeters for the bigger circle and 12 millimeters for the smaller circle. So let's start from there. So if we go back to our Inventor, I will start a new file by pressing Ctrl N on my keyboard. The create new file dialog box is going to come up. In the browser on the left, the metric system of units is already selected. Okay, because I'm working in millimeters, I'm going to stick to it. Okay, so I'm going to select the standard part file in millimeters and click on create. I might as well double click. I'll be doing that alternatively, so you see the various methods of doing that. But now I've selected the standard part file in millimeters, and I'm going to go down to the bottom right hand corner of the dialog box, and I'm going to click on create. Okay, take a few seconds and it will open up the part file working environment. Okay, which is where we are currently, and of course you know all the various aspects of it as we have explained in class. Each of these are called tabs, right? As you go along, you see the various tools in the tabs. Every tab is broken into panels, so you see that vertical gray line there. So let me zoom in a little bit so you can see. So there is this first tab here under the 3D model. You see that the 3D model is highlighted as opposed to all the other tabs, right? And under it, we have a sketch panel, and then we have a create panel where you have various tools that are used to create three-dimensional objects primarily from 2D profiles. And then you have the modify panel where you modify an existing 3D model, and so on and so forth. Okay, so you know all of those. Then right here is what we call the view cube. You know what the view cube is used for? It's used to view the workspace from different perspectives. It's used to orientate your model in different ways to facilitate your ability to view it from different angles. Then you have the navigation bar, right? The navigation bar where it has tools that are used to navigate the workspace. You can zoom in, you can zoom out, you can pan by moving the workspace around. You can revolve and the rest, right? Here you have your coordinate system right at the bottom that shows you the way the model or the workspace is orientated. And then here you have the model browser that has a collection of all the work features and the features that you will create for the particular model you are dealing with. All right, so I'm going to start by clicking on the Start 2D Sketch. Okay, I will have to select a plane or 2D profiles I've drawn on planes that I want to draw. So I'm going to select the X, Z plane. I'm going to orientate it properly so that when I want to deal with the constraints, the vertical constraint, horizontal constraint, I wouldn't have an issue. I'm drawing two circles. So I'm going to select the center point circle tool, right? And because I want it to be fully constrained, I'm going to locate it right at the origin. Okay, so once I go to the origin, you see that it's highlighted. Let me take off that. So you see that when I go there, it's now yellow, but once I get to the origin, it becomes green. It shows that it's locked in. Okay, when you check my options, snap to grid is on. So what happens is as you go near a feature, your cursor or your pointer will get magneted to that particular feature. Okay, let's turn back on the highlight so you can keep following my cursor. So I'm going to click at the origin once and move my mouse out. Okay, the first circle had a diameter of 20 millimeters. Enter. That's a little bit small, so I'm going to zoom in so we can see it. Now my circle tool is still selected. When you look at the circle tool, that center point circle tool, it is still selected, so I can draw as many circles as I want. So I'm going to come back to the middle, click and drag out. The second one has a diameter of 12 millimeters and enter. I'm going to right click to drop an active tool and click on OK. Okay, or where's my OK? Or you press the escape key, right? It's already dropped. Okay, now when you look at the bottom right hand corner, it tells me that my sketch or my 2D profile has been fully constrained, and so I can safely finish sketch and exit the 2D environment and come back into the 3D environment. Now I'm going to extrude, so I'm going to pick my extrude tool. The extrude or extrusion dialog box is going to pop up. I need to select profiles because I've drawn more than one profiles. Inventor doesn't know which particular one I need to extrude, and so I need to select, right? I'm going to start with the 12 millimeter diameter circle. Its default extrusion is upward, so in behavior, I'm going to flip the direction. It goes down, right? And it's going to go down by 33 millimeters. Is this 33? Yes, 33 millimeters there. Okay, now that's what I want. I will not say okay because I still want access to this other circle, so I'm going to apply. I'm going to apply that extrusion by clicking on that green plus icon there. Okay, then I now select, I want everything. Okay, so just hover until the whole thing is selected. I select all of that. Okay, now it by default has extruded it upwards by 33, but the dimension I want is 27. Okay, all right, that's what I want. Now in the output, you have all the Boolean properties. I'm choosing join because I want it to be the same parent material and the same body as what I extruded downwards. So you can do join, you can do cut, which takes away the volumes that intersect in both models that you've created. You can do intersect, which keeps the volumes that are common to both or all the models available. Or you could create a completely new solid that has its own material properties different from the one that you've created already. Okay, so I'm happy with this. I've gone 27 up and that down. I click OK, right? That's quick. So when we come back here, we have done the shank, okay, the this and that for it. So now let's do the dome. Remember again that there's a circle, a base circle that it sits on that is 40 millimeters, and the dome itself has a radius of 22. That means it has a diameter of 44. When we're drawing circles in Inventor, we draw with diameters. Okay, so what we need to do is to see one of the planes. Let's look at the planes. I think I'll rather use the XY plane. I'm going to make it visible. You can make work features or work, visible by right-clicking on them in the model browser and clicking on visibility to turn them on. Okay, so we can now see that. Okay. So that's what I want to draw on. Okay, so I'm going to hover over the plane until it's selected. Then I left click, not right click, you left click, and then you select the create sketch tool. Okay, so it has reorientated that to face me directly because I'm drawing on that particular plane. I'm going to go right down to the bottom and click on slice graphics. So it removes the part of the model between me and the plane that I want to draw on so that I can see everything I'm drawing directly. If I click the home key, you can see that it has basically sectioned this and removed the portion of the model that is between me and the plane that I want to draw. I'm going to go back there. Right. So I will draw half. So if we take a plane and cut it right down the middle of this, right, and view it, you will see something that is like a segment of a circle. Segment. Okay, not the semicircle itself, just a segment, right? And we need half of that. If we get half of it and we revolve, we will have this dome. So at the bottom, the diameter is 40. That means half of it will be 20. So I'm going to pick the line tool, escape, I'll drop it. Before I do that, I'm going to project those features out so I can easily see them. So I'm going to pick the project geometry tool, and what I want is I want that line to be projected to the plane where I'm drawing, so it becomes a line I can reference. Okay, so I pick my line tool, and I'm going to go to the midpoint. Again, let's turn on the highlight so you see. As I move along this line. When I get to the midpoint of that line, it becomes green, right? So that's where I want to start. So I click that and I move out. Let me bring back my highlight. Well, I want that to be perfectly horizontal, so the angle should be 0 degrees, as you can see right there. Okay, that's what I want. So let's leave it at 0. The highlighted heads-up display is the one for the length of the line, and I want it to be 20, which is half of 40. Okay, right? I'm happy with that line, so I'm going to right-click and say OK. Okay. Now, having drawn that, sorry, this is dancing around. I now need to draw the circle that is meant to touch this. Actually, I will need this second aspect of this line before I delete it, because I will need my circle, the circumference of my circle, to be coincident to both of these. So again, this is going to be 20 and enter. Okay, right click, and I'm happy with those lines. Then I go to my center point circle tool, click on it to make it active, come somewhere here and click and drag out, or click and move out. Okay, when you say click and drag, it looks like you click and hold down your mouse button, but no, just click it once and then move your mouse out. The diameter was 44 because 2 times of the radius of 22 will give us 44. So we input 44 and click on enter. Right? So I'm going to pick the coincident constraint from the constraint panel, right? And I'm going to go to the end, all right? The end point of that line. That point, I need it to be coincident, to lie on this circumference, right? And then I come back to this side and I pick the end point of this other line, and I want it to lie on that. So that fixes the dome, as it were, the way we want. So I'm going to come back here, pick the line tool, and from the midpoint, draw a line up to the circumference of that circle. And I'm happy with that. Now I can trim off and leave half of this and revolve. So I'm going to delete my dimensions so they don't interfere when I'm trimming. Okay, if you have your dimensions on, sometimes you can't trim off certain aspects of your sketch. So I'm going to go to the modify panel, pick my trim tool, or you right click. Your trim tool is always available in the options. So I pick the trim tool. That whole part of that circle is of no use to me, so I cut it off. This is how the cross section of that actually looks like. But because we are going to revolve, we only need half of it. So I delete that and delete this line, right? So we have this as what is left. Now, right click and OK to drop the tool. When I look at the bottom right hand corner, it tells me there are 3 dimensions that I need because I deleted all of that. Let me attempt to fit them myself. I know that that's 1 dimension that I need, right? This is another dimension that I need, and then I need the radius. Okay, let's just leave it that way. Now, if I did not know where these dimensions were, I could have simply clicked the automatic dimensions and constraints tool from the constraints panel to apply all the dimensions that are needed to fix the particular 2D profile I've drawn where it is currently and in the shape and size that it is. All right, bottom right hand corner is fully constrained. I think I can bring back my highlighter so you can know where my mouse is. The bottom right hand corner is fully constrained, so I'm going to finish sketch. Now here, in the create panel of the 3D model tab, I'm going to select the revolve tool. Okay, I've drawn 1 profile, so it has automatically selected that profile. However, there are 2 possible axes that it can use, so it's waiting for me to select. If I had used one of these as a center line, it will automatically select that as the axis to revolve around. Let me show you what I'm talking about. Let me cancel this go back to this sketch, right click and edit the sketch. So it brings me back into this sketch environment. Now, if I select this line, okay, and I go to the format panel and I choose center line, what I'm saying is make that line a center line. So you see that it has become a dotted line, okay, which indicates a center line with the characteristic dots of one long, one short, one long, one short. Okay, now with this, when I pick the revolve tool, there is one profile I have on my sketch and there is one axis. So Inventor will automatically pick that profile and revolve it around that center line. So watch, once I click on the revolve tool, okay, automatically. So you see that it has created that dome shape. It has picked that half segment that we've drawn, and then it revolved it around the particular line I said was the center line. There's nothing else I need to do. I'm happy with that. So I say okay, right? And there we go. You have the pin. Now I will turn off this plane so that we can see it. But before I turn it off, we have a hole here. Now the peculiarity with this hole is that the diameter of this hole on this end is different from the diameter at the other end because we have a pin that tapers. We did those calculations in class. You go to websites or you find a data sheet for tapered pins. We're looking at number 2, and then they give you all the dimensions that are needed, right? When we checked, even though it was in inches, we converted them. The bigger diameter, so if you see where my cursor is, the bigger end, oh, I don't want that there to show. Okay, good. The bigger end of the taper pin from the data sheet is about 4.8514 millimeters. Okay, and we are told that the pin tapers, it reduces in dimension by 6.35 millimeters for every 304.8 millimeter length. In inches is a quarter of an inch or 0.25 inches per foot. That's what we converted to millimeters to give us the values that we have. Now, when you convert that and you see that the pin that we're dealing with has a length of 38 millimeters, right? It means that what it would have reduced, if it reduces by 6.35 for a length of 304.8 millimeters, you run a proportionality mathematics calculation there, you'll find that for 38 millimeters, it drops by 0.792 millimeters. Okay, so if the bigger end of my taper pin has a diameter of 4.8514, then we take out 0.792 from that value to get the diameter at the smaller end, which will give us 4.0597 millimeters. Keep that in mind because we're going to use those two now. So what we're going to do, because it keeps reducing, what we're going to do is to assume that this pin is already in here, right? Now, if you look at the model, this model fits into the bushing. The bushing here has an outer diameter of 25 millimeters and internal diameter of 20 millimeters. Now, when you look at this guy here, it has an that's this where my cursor is. It has a diameter of 20, so that fits into the bushing, right? That fits into the bushing. The bushing's length is 25. This one's length is 27. So there's going to be a 2 millimeter clearance when that bushing sits at the pin exactly. But that's not where I'm going. When you look at the bracket where the wheel is going to be fitted, right, you see that there is this hollow, a cylinder with a 12 millimeter hole at the middle. Now you see again where the taper pin is supposed to go in, right? That taper pin is 6 millimeters. The center of the hole where it will go in is 6 millimeters from the bottom. Now, if the total height of the cylinder is 30, what that means is that the center of this hole is 24 millimeters from the top, right? Now, oh, that's too big. Now, when you put this pin in there, all right, this is 33. This is 33 millimeters, right? And that is 30. But this 20 millimeter diameter cylinder will sit on this guy. Okay, so we can start counting the 24. So what that means is that from the top of this shaft here that is 12 millimeter in diameter to the hole is 24 millimeters. Okay, 24. So what that means is that from the hole, the center of the hole to the bottom will be 33 minus 24, which is 9. So let's keep that in mind. So what I want to do now is to come back here and create two different planes, okay, symmetrical about this center plane that will be where the taper pin starts and where the taper pin ends. Remember, the full length of the taper pin is 38 millimeters, right? So if this XY plane is bang on in the middle of the pin, then we need another plane to its left by a distance of 19 millimeters, because if you divide 38 by 2, you have 19, and another one to the other side by 19. So I'm going to go to the work features panel. I'm going to drop down the plane, and I'm going to select the tool that says offset from the plane. So I'm looking for a plane that is offset from an existing plane or face, right? So I'm going to select this, right? That's show me the direction, and I want it to go there by 19 millimeters. I'm going to click OK, right? And I'm still going to come back here and select offset from a plane, offset from this plane. Now I want it to go the other direction, so I'm going to put a negative number there, minus 19 instead, right? And OK. So now I have those two planes where the taper pin would begin and where it will end. The distance from this plane to that plane is 38, right? Now I don't at the moment need this guy, so I'm going to turn it off. Okay, but I need these two guys. So I'm going to hover over the first work feature, the first plane, click on it, left click, and select create sketch. Okay, that's going to bring me into this view. Okay, I want to refer to that line down there, so I'm going to project that line to the plane I'm working on. So there, you see the yellow line where it's been projected. Now I'm going to pick my center point circle tool and draw the diameter for the bigger end of the taper pin, which is 4.8514 millimeters, right? And I click enter. Okay, right click and OK to drop the tool. What's going on with my right click and OK to drop that tool. Now I want this to be vertically above the midpoint of that line, so I will pick the vertical constraint, all right, and I'm saying let the center of this circle be vertically above the midpoint of that line down there, right? Then I pick my dimension tool, and I'm saying that the center of this circle, the distance from that center to the bottom, should be 9. Remember, we said 33 minus 24. That will give us 9, and enter. So we fix exactly where this guy is. Bottom right hand corner is fully constrained. I'm happy. I finish my sketch. Then I'm going to orientate this way so I can draw on the back side of this plane. I'm going to hover over it. When it's highlighted, I left click and click on create sketch. Okay. Here again, I want to project that bottom line to the plane I'm drawing on. I'm going to pick my circle tool again so that I don't create confusion. Let me just put it there. Click and drag out. This one's dimensions or diameter is 4.0597 according to the calculations that we've done. Enter, and that's it. So I'm going to pick the vertical constraint again, and I want the center of that circle to be vertically above the midpoint of the line down there. And I pick the dimension tool, I click on the center of that circle and the line there, and I want the distance between them to be 9. This aligns, okay, the first, this aligns this circle with the first circle that I've drawn. So we finish sketch, we're happy, and there you go. You have two different circles with different diameters or dimensions on different planes. Now, to create a volume between these two guys, I need to use the loft tool. That's what the loft tool does. The loft tool creates a volume between two 2D profiles. They can be of different shapes, they can be of different sizes. In this case, I have the same shape, which is a circle, but different sizes. You could have different shapes. You could have a circle and a square. You will still have a volume created between them. So I'm going to click the loft tool, and it is going to ask me to select the profiles that I want to link up. And the mode of linking, I want them to link their edges, so edge to edge instead of center to center. All right. And then again, you have Boolean options. Do you want to create a volume between these two? That's what's currently, or do you want to cut out the volume between these two from anything that's existing? It's the cut that we need, but before we do that, let's just select. So you see as it creates that. So that's the first circle. So I'm going to come back here and select the second circle. So you can see that it has created that pin that tapers down, right? But I want to cut it, so I'm going to go to the Boolean options and click on cut. So it's going to remove that material from whatever is existing. That's all I'm looking for. So I'm going to click OK, right? So immediately you can see the hole on this end. And if we take this way, you can see the hole on that end. The diameters are according to the taper of the pin. Great. So that's that for that. So I no longer need these planes to be visible. So I'm going to toggle off the visibility. What is left in this pin is the chamfer, right? We need to chamfer the bottom. So we go to the modify panel and select the chamfer tool. The diameter, the distance we're chamfering is 1.5, okay? And because it's an equal distance from the corner, okay, the angle between them will be 45, so there's no need to put in that. So I want a chamfer of 1.5. Now I need to select the edge, right? Once I select that edge, it gives me the chamfer I'm looking for, and that's us done, right? So there you go. You have the pin. So let's save this. We'll save this as a pin. Yes, I've created a folder called video exercise. So I'm going to save that as pin, right? Very quickly, I'm going to select the material. I'm going to make all of them. Well, for this one, I want galvanized steel because it shines. I'm going to select galvanized steel, and that's that. I'm happy with that. I'm going to save. Great. So we finished the pin. Now let's quickly jump and do the bushing. The bushing is straightforward, right? I beg your pardon. No, I don't want that. Okay. That covers. So the bushing is quite straightforward. We have an outer diameter of 25, an inner diameter of 20, and a length of 25. So very straightforward. We start a new file, Control N, right? The create new file dialog box comes up. We select a standard part file in millimeter. This time I'm going to double click, and then it's going to open up that file, right? I'm going to start by creating a 2D sketch by clicking the Start 2D Sketch tool, and then I'm going to select the plane down here. Excuse me. I'm going to orientate that properly. Pick the center point circle tool. Click at the origin, drag out. The outer diameter was 25. Enter inside. Zoom a little bit. Go back to the origin. Click again. Drag out, and then 20. Okay. That's all we need. Right click or escape. It's fully constrained. Finish sketch. Okay. That's what I want. So pick my extrude tool and select the profile area. That's the area I want extruded. Select that, and I want it to be extruded by 25. That's all I need. Okay, so selected that. Okay, again, we save this. We're going to save this as the bushing. Okay, now material, I will choose stainless steel again, but maybe not the it's a bushing. Bushing should be smooth. Let's choose the galvanized, or okay. Let's just choose the austenitic. All right, great. But because to aid my assembly, so that when we assemble, we can see the differences, I'm going to color this differently. So I'm going to choose a smooth polished color. Where are you? Just give it a minute. Okay. A smooth yellow, no. Smooth light orange, no. Uh, Smooth purple. Usually says purple. Yeah, I'll leave it purple so we can easily identify it. It's just the color. Okay, so I see we sprayed it. All right, I'm going to save that so it has that. Now, what's the next thing that we need to draw? Excuse me. We need to draw the wheel. All right. Now you need to recognize that the wheel is made up of a lot of circles, right? We can have that approach where we draw circles, extrude, cut out, join, and all of that. But the easier way of doing this is to cut this wheel just as has been done. They've given us a part section here to show us the thickness of that middle portion, right? But if we continue this cutting plane all the way across, you will see that on this side, what you view, if you look in this direction, will be like an H shape. H. Okay. Now the thickness of this outer one, if you look at the diameters, the outer circle is 90, the inner circle is 80, right? So if you subtract 80 from 90, you have 10. But because it's on both sides, we'll divide that by 2. So this thickness here is 5. Okay. The height has been given to us as 25. Okay. If we want to know the length from the inner point, this inner circle to that, this circle here is of a diameter 37 millimeters. So we need to subtract that from 80 and divide by 2. If you subtract 37 from 80, you have 43. If you divide 43 by 2, you will have 21.5. So the distance from this point here to that point is 21.5. Now to know the thickness here, we subtract 25 from 37, okay, which should give you 12. And so if you divide 12 by 2, you have 6. So this has a thickness 6, okay. And then the middle or inner hole has a diameter of 25. So it means that the distance from the center of the hole to the circle is 12.5. That's 25 divided by 2. So with that, we can easily draw that cross section and revolve it around. Okay, so note those dimensions and we're going to draw them very, very quickly. So Control N on my keyboard. There are several other ways to start a new file. I've taught you that in class, so I'm not going to waste time on them anymore. Standard part file in millimeters. So we have the file now. I'm going to create a 2D sketch. I'm going to select the XY plane, all right, to draw this on. Now I'm going to use my rectangles, my 2-point rectangle tool. That's what I'm going to use. So I'm going to first do the first rectangle that is closest. Its diameter, its breadth was 6, right? And the height is 25. Okay, enter. That's the first circle. I beg your pardon, the first rectangle. Then the next rectangle is this one here, that is the length of it was 21.5, right? And then the width was 6. Okay, and then we have the third rectangle. The width was 5 and the height was 25. That's basically what we have, right? I'm going to pick the coincident constraint, find the midpoint of that rectangle and make it coincide with the midpoint of this so that becomes 1. Then the same thing here, find the midpoint of this and find the midpoint of that. And there we go. Then I pick the horizontal tool, right, in the constraints panel, the horizontal constraint. I select that point and I want it to be on the same horizontal line as the origin. So there we go. And I pick my dimension to the distance from this side of the shape I've just drawn to this should be 12.5. 12.5. That's half of 25. There we go. So this is all that we need. Okay. I will not trim because I don't have time. It will still produce, once I select this profile, and this profile, it will still select and I choose join, it will still produce the same one model. But you could as well trim off this inner part so you see the whole shape itself. But I'm happy, bottom right hand corner fully constrained. I'm going to finish sketch. Oh, no, I cannot finish sketch. You know why? I have not, so I'm going to edit sketch. I have not drawn a line that will act as my center line. So I'm going to pick my line tool, start at the origin, take a line vertically upwards, and I can just make it 14 millimeters. It doesn't matter. Okay, right click and OK. Again, I will select that line, go to the format panel, select the center line at the format panel to make that a center line. So when we go closer, you can see that acts as a center line for this whole figure. Great. So we can now finish sketch, come back to the 3D environment, and then we select the revolve tool. Okay. Now there are multiple profiles. That's why it has not automatically selected and revolved. But once I select them, you will see that it should select that axis. So I want this and this and this, all three of them to be revolved. And I need to select the axis about that. So just one axis, immediately I selected that, is selected automatically. So there you go. That's the wheel. That's the wheel. Okay. So I'm happy with that. That's me done with the wheel. Let's save it as the wheel. Okay. Material type stainless steel, stainless steel, or rubber. Let's make it rubber because it's a wheel, right? Let's make it rubber and it's black. That's great. Okay. So let's save that. What do we need to draw next? The brackets. Now, do note, it's very, very key to understand that every complex shape you find is made up of little or smaller. You can break it down into smaller, simpler shapes. Okay. Now, looking at this, you have to think, so which profile do I draw first to give me which 3D part of this element or this model? Okay. Now, when we look at the base, okay, when you look at this dimension here, it says what? 60. That's the distance from the top there right down to the bottom. Okay. Then from this side all the way to that side, there's this dimension here that says 75. So I have a basic rectangle there, but filleted. So these sides are curved. You can easily do that with fillet. It's filleted with a radius of what? Of 25. Okay. But then the thickness of this is 12. Now I'm seeing a circle here. This is telling me that there's a 12 millimeter drill. There are two holes, one on this side, one on that side. The distance of that hole from this upper end is 35, okay? Which means that what is left here is 25, right? And then the distance from center to center, both holes, is 48. That's what this is here, 48. Now, if the whole length is 75, right? 75 minus 48 will give you 27, right? I'll give you 27. If you divide that by 2, you find the distance from this edge to that center. 27 divided by 2 is 23.5, right? 23.5. So that's the distance from this edge to that. Now have that in mind. Let's first now go and draw that. So start a new file. I'm going to go to the quick access menu and click on the new there. It brings up the create new file dialog box, and then I click on the standard part file in millimeters and click on create from the bottom right hand corner. In a few seconds it brings me into the file I've just created. I'm going to start 2D sketch, and I'm going to select the plane. I'm going to select the YZ plane to draw that in. Can I use the center point rectangle too? Well, let's still use the 2-point rectangle too. No worries. I'm going to click it from up there, drag down. The dimensions are the height is 65 and the width is 75. Enter. Okay. So there's this very big stuff that has been drawn. I'm going to pick the coincident constraint, and I'm going to fix the midpoint of the bottom line to the origin, so that shape shifts up there. Now, I could at this point provide the fillet, but I'd rather do that in the 3D space. So I'm happy with this. Next thing is the circle. I'm going to pick a circle, click here and drag out. The diameter of that circle was 12. Enter. Okay, there's another one this way. Diameter is 12. Enter. Okay, pick my dimension to the distance from the back end or the upper end of this guy to the center of this was given to us as 35. Okay, I'm going to pick my horizontal tool. Okay, it's vertical tool that works in this case, and I'm going to say let the center point of this circle be on the same line as that. Okay, that fixes that. I go back and pick my dimension tool. The distance from this guy to this edge, I did calculate it to be 23.5. That's 75 minus 48 is 27. 27 divided by 2 is 23.5. So 23.5, enter, right? And then the distance from this to this was given to us as 48. Something is wrong somewhere. There's the mathematics that is wrong. Let's check again to see. Let's zoom in. So from here to here is 75. Let's say 48 from center to center. Is my math wrong? 75 minus 48. What value does it give you? 75. That's my pen. 75 minus 48 should give us 27. 27 divided by 2. Oh, 27. 13.5. So 13.5, not 23.5. That's what made a mistake. So we're going to click on that, and the answer is 13.5, right? There we go. That's more like it. That's it. Now everything is fully constrained. I'm happy. I'm going to finish this sketch. Now I'm going to extrude, and I'm extruding by 12. So when you come back here, you see that the thickness there is 12, right? Let's zoom in again so you see. The thickness, the thickness is 12. So I'm going to pick the extrude tool. Okay, I'm selecting that profile, and I'm extruding by 12. Okay, and I'm happy with that. Now I pick the fillet tool from the modify panel. I'm filleting this particular edge, and I'm filleting by 25. Okay, and then I'm also doing the same with that edge, 25 by 25. I'm happy. Okay, so there we go. We have that base. Now the next thing that I would like to add, the next feature, let me add this long aspect that comes here like this. The length, you see there's a 95 here that says from the back end of what I've just created up until the center of this cylinder is 95, right? And then what's it called? The width of this is the same as the diameter, because look at how it flushes into that. It's the same as the diameter of this cylinder. So I take the width to be 38. So I'm looking for a simple rectangle 95 millimeters by 38. And then when I am extruding, I'm extruding downwards by 7.5. Keep those dimensions in mind. So in my sketch, I want to sketch on that face, right? So I hover over the face until it's highlighted, left click, and select create sketch. Okay, so that's going to come up this way. This is where I'm creating the stuff I want to create. So I'm going to pick my 2-point rectangle tool. Okay, well, this is fine in this case. I'm going to pick my 2-point rectangle tool, click and drag out. Don't bother about where I've clicked, because I'll use my coincident constraint and arrange it. This width or the length was 95, right? And then the width was 38. Okay, and let's enter that. That's how long that is, right? So I'm going to pick my coincident constraint to look for the midpoint of that line, and I want it to coincide with, oh, I did not project, did I? Oh no, it's there. Yeah, bang on, that's what I want. Right click and OK. It's fully constrained. I'm happy. I finish sketch. Great. So now I'm going to pick my extrude tool, select that, automatically it goes up, but I want it to go down, so I'm going to flip it down, but it's also selecting cut. I don't want cut, I want it to join, give me a new material, but go down by 7.5, right? Now that's what I want. I'm happy. I click on OK. Excellent. Now, having done that, the next thing I want to do, if you look at it, there is a fillet here of radius what? 6, and it's on both sides. It's both there and here, right? You have that fillet of radius 6. I'm wondering whether it's the same on that corner. It is. So what I'm going to do is to come here, pick my fillet tool from the modify panel. The radius I'm working with this time around is 6, so I've changed it there to be 6. Now I need to select all the edges that I want. So I want that edge, right? I want this edge. Then I can orientate the view so that I can see this edge and this edge. All of those have a radius, a fillet radius of 6, and that's all. I'm happy with that. Okay, right? So let's go back home. So it's beginning to look more and more and more like the great. So having done that, I want us to now do this feature before we come to the cylinder. This feature here. Now, when you look at it, there is a distance of 3 millimeters from the end of that to where this feature stays, right? That's the first thing to note. And then the feature has a length of 50 millimeters, right? Then there is a circle of radius 45. That means diameter will be what? Will be 90. Is that okay? Excuse me. It's radius, that means diameter will be 90. And then the distance from this bottom portion of that feature to the apex of your curve they've given us as 10. Okay. So how do we achieve this? And obviously that thing is symmetrical about the whole model. So what I'm going to do, I'm going to draw a rectangle. Okay, length will be 50, height will be 10, right? Then I draw a circle of diameter 90, okay? And I will do a tangent between that circle and this side of the rectangle that I draw, okay? Once I do that, it's going to fit that where it should fit, and then I trim off every other thing that needs to be trimmed, making sure that everything is symmetrical, okay? But the bottom of that rectangle has to be 3 millimeters from that. Then when we come to extrude, we extrude by 35, okay? So let's get, now I'm drawing on this face, so I'm going to hover over that face until it's highlighted. I'm going to left click and then click on the create sketch icon. Okay, now I'm going to zoom in a little bit. I'm going to pick my 2-point rectangle tool somewhere there. I'm going to draw that. The thickness again was 10, right? Tab. The length was 50. Okay, that's been done. I will pick my horizontal tool and select the midpoint of this rectangle coincide with the midpoint of that line that way. Okay, there it goes. I pick my dimension tool. The distance from this side of the rectangle that to this should be what? Should be 3. So put 3 millimeters and enter. Okay. What's left? The circle. So I'm going to put the center point circle tool. I'm going to draw a big circle. What's the diameter? 90, because the radius is 45, right? So here we go. I'm now going to pick my tangent constraint from the constraint panel. So let this circle be tangent to this line. Okay. Then I'm going to pick my horizontal constraint that say, let the center of this circle lie on the same horizontal line as the origin. Right click and OK. Or right click. Yeah, let's do OK first. Okay. So fully constrained. Yeah, that's exactly what I want. But the shape I want is this one. That, this, that. So every other thing I don't want. So I'm going to select all the dimensions and delete so I can trim freely. I'm going to select my trim tool from the modify panel. The big side of this circle I do not need, so I trim that off. And I come back here. I do not need that length and I don't need this length, right? Similarly, I don't need that length and I don't need this length. So there you go. That's the feature that we require. Okay. Now, 5 dimensions are needed. I'm just going to ask Inventor to automatically apply that by clicking the automatic dimensions and constraints tool to say 5 dimensions required, both dimensions and constraints. That's absolutely fine. Kindly apply. It has done all of that. Nothing else is needed. Bottom right hand corner is fully constrained. I'm going to exit the 2D sketch environment back into the 3D. Now I'm going to extrude. And remember, I'm extruding by 35. Okay, so I will pick the extrude tool. It has just one feature, so it's just going to select that. So I'm extruding up by 35 and it's going to join the same body as the previous ones. There we go. Are we not getting closer and closer? That looks beautiful, isn't it? It does appear, I don't know whether there's a small fillet there, but I'm just going to ignore it. Now, the next feature to do is this cylinder. Okay, it's very, very simple. Okay, the outer diameter is 38, the inner diameter is 12. All of them are bang on located at the middle. So we get to the midpoint of the edge of this feature we just drawn, and we draw those 2 circles, and then we extrude. Now, but follow the extrusion system. It's extruded up by 9.5. Okay, from that face upwards by 9.5, right? Now, the whole length is 30. 30 minus 9.5 will give you 20.5. So if I'm going to extrude, when I extrude from this plane upwards, I'll extrude by 9.5. But from this same plane downwards, I'll be extruding by 20.5. So do take note. So here we go. Where we want to draw is here. I'm going to left click and click on create sketch. And then I'm going to go to my center point circle tool. I'm going to select that. I'm going to locate the midpoint of that. Let me remove the highlight so we can see when it gets to the midpoint. That's the midpoint. So I'm going to select that. I'm going to just take it right down to there. So it's bang on 38. That's what I want. I'm going to come back to the middle, select that, and this time around the diameter is 12. That's all I need. Right click and OK. It's fully constrained. I'm happy. Everybody's happy. We finished sketch. Okay. So back here, do note that I want this part here to extend, but there's a portion here that must be cut. So I'm going to start with that one. I'm going to select the extrude tool. Okay. I will select that portion, just that portion there. Okay, but I do not want it to be another feature. I would rather want it to cut. So from the output options, the Boolean, I'm going to select cut, and I'm going to cut through all that is existing. I will apply. Okay, I'm going to apply that. Now, I now come and select that feature and this feature. Okay, and I want it to be extruded upwards by downwards. No, I want it to go upwards by how much? By 7. I mean, it was 7.5 or 9.5. It was 9.5. That diameter there is 9.5. Sorry, my brain just went blank for a minute. So this is 9.5. Okay, that's exactly what I want. So I'm going to apply. Okay, and then I'm going to select that again, and this time around we want it to be solid and we want it flipped. Okay, no, flipped downwards. The distance is what? 20.5. Okay, now that's all we need. We're happy. We okay that. You can inspect to see whether this is actually 30. Let's go to the view. Okay, sorry, where is my inspect? Sorry, inspect and measure. So I want to measure distance from there to here. Okay, what does it give you? 30. Okay, there you can see it, 30 millimeters. So excellent, that's what we want. I'm done. Let's go back to the 3D model tab. So now we have this guy. Okay, something is left, the web. Now when you look at this, there is a web. Okay, if we look at the, where's my cursor? I need my cursor to be close. Oh, I turned off my highlight, that's why. Let's turn on the highlight so you can see when it's moving. Good. So there's a web here, right? Look at that, 8. The thickness of that web is 8, right? And it seems to link up this cylinder with this part of the bracket and that part to provide rigidity for it. So when you drive, you hold this bracket by bolts, this bolt and that bolt against a face. The wheel here has that support. Okay, it provides rigidity and prevents bending moments on this member. Okay, so how do we draw that? We would need that plane that cuts through this. So I'm going to go to the origin folder in the model browser, drop down and find the plane I'm looking for. It is the XY plane. So I'm going to right click and make it visible. Okay, so I'm going to hover over that, left click and create a sketch. Okay, this is where I want to create this sketch. I'm going to click on slice graphics, okay, so that I can see exactly what I'm going to draw. I'm going to pick my line tool. I think I need to project first, so that project geometries, I need that corner. It came and disappeared. Right. Anyway, I can project that line, okay, so that I know where it stops. What else do I need? I can project this line, I can project this line, I can project this line, I can project that line. So I'm going to pick my line tool. I'm going to draw a line from here. The reason why I projected was so that I can easily do snap to grid, okay, and get the exact. So let's zoom in so that and I want that to stop here, okay, and then I want that to, now that is a circle, right? If I do it bang on, if I Control Z, if I do it exactly at that point, what will happen will be that your circle will curve, and then you will just have the wedge just touching the circle at one point as though it were a tangent. Okay, so the line I'm going to draw from here, I will take it a little bit in, so that even though the circle curves, you wouldn't have that. So instead of staying bang on there, I'm going to move up a bit. Okay, let me make it 67 is fine. 67, enter. Okay, and I'm going to move this way at 90 degrees to that point, right? And then I'm going to move down to that corner there, right? And I have one more line to draw from this corner to that, because I need to provide a closed shape for extrusion. Right click and OK. Right click and OK. One dimension needed. Kindly apply it for me. I don't know where it is. It's applied. Done. Right. So I'm happy with that. I'm going to finish my sketch. Now that sketch is bang on in the middle of this. So when I extrude, I'm going to do a symmetric extrusion to extrude it both sides. So I'm picking my extrude tool. There's one shape I've drawn, so it has selected it. it's coming all this way by 20.5, but the extrusion is by 8, right? And I'm going to choose symmetric. Okay, so it goes both ways, right? And I'm happy. I'm joining it with the existing, and I say okay. All right, so I can toggle off that, but I won't yet because I need it. But if I rotate this way, you see what we just did. Somebody might argue, rightly so, that in the image itself it doesn't join. Well, we don't know, we can't see, but I do not believe it joins it that way because something's supposed to sit at the top. So what I will do, I will go to the sketch and edit it such that this line passes through that point and doesn't stop that. So this is the extrusion we just did. We drop it down. I'm going to right click and edit that sketch. Okay, so what I will need to, I need slice graphics as well so I can see. Good. I'll have to delete this angle. Then I delete that line. I'm going to delete this line. So what I will do is to pick the line tool, pick that corner, make sure that it goes through that corner, right, like that. Let's zoom in so I see, right, and click on that, right click and OK. Pick the line tool. Where did I stop that line? It was here. Pick that and keep it at 90 there, right click OK. Pick the trim, don't need that, don't need that. Great. In that way it passes there. One dimension is needed, kindly fit, that's the angle. Apply, done. Finish sketch. Let's see. Errors, cancel. Finish sketch. It will still give me the errors. Accept it. What I will do is I will delete that feature and extrude that first. Delete, but do not delete the consumed features sketches so that I can redo. Great. Now I can extrude, pick that, extrude by 8 on both sides. Okay, I'm happy. So now you see that this ends just where that begins, and that looks neater than what it was before. Okay, great. So now we've done that. There's one more feature here that is left to be done. Okay, and that is the hole for the taper pin. Again, we will do exactly what we did before. I'm going to go to my work features panel, select my offset from a different plane, right? I'm going to click on that and I'm offsetting by 19. Okay, enter. I still want to offset the second one, same plane, but now in the opposite direction by minus 19 and enter. Okay, all right. I do not need this one now, so I'm going to toggle you off. But again, we are going to now draw on these planes the same thing we did before. Sketch, and on this plane I will project that line, right? Then I pick my circle tool somewhere here. The diameter is 4.8514 millimeters for the bigger circle, right click and okay, right click and OK. I'm going to pick the vertical constraint. The center of that circle should be vertically above the midpoint of that guy. Pick the dimension tool. The distance from the center of that circle to the bottom in this case was 6. Don't forget, for this guy it is 6. You can easily see that in that image there. Okay, so we will go. I think we'll finish sketch. We'll finish this one. Then we will come to this other side and draw on this plane. Left click and create sketch. Okay, we are doing the same thing. We are going to select a circle. Click that's the center point circle tool. and the diameter this time is 4.0597. Enter. Okay. We're going to project. I forgot to project that line. We're going to pick the vertical constraint. The center of that circle should be vertically above the midpoint of this, right? And then next thing, distance from that to the bottom should be 6 millimeters. Okay, right? Fully constrained. I'm happy. I finished sketch. Now this is where I create a loft. So I'm going to select my loft tool, right? First is this shape on this side. I'm going to select that shape. Second is this shape on this side selected, but I want it to cut through, so I'm going to select cut and click on OK. And there you go. You see the hole beautifully made. I can toggle off the visibility of these work planes. Okay, so let's click on home in the view cube, and there you have it, right? We have the bracket with the hole for the taper pin and every other feature as is in this drawing. The last thing to do is the taper pin, but let's save this. We're going to save this as a bracket. Okay, save this bracket. We're going to make it stainless steel also. It's a bracket. It should be strong, but we're going to choose steel, high strength, low alloy. I like that color. Well, so that we can see different things. I can color this maybe weld brass. No, I don't like that color. No, that looks horrible. Let's go to smooth. Let's do smooth green. Smooth dark forest green. Yeah, that's fine. That's fine for the bracket. So Control Save. The last item to draw is the taper pin. So again, like we did before, Control N, create a new file. Standard part file in millimeters is going to open up. I'm going to start 2D sketch. I'm going to select the XY plane. On this plane, I'm going to draw a circle bang on at the middle, and the diameter of that circle is 4.8514, right? And enter. That's all I need here. So right click and OK. Fully constrained. I'm going to finish this sketch. Now I'm going to make the plane I just drew on visible. This is the XY plane, and I'm going to get a new plane offset from this plane by 38. I'm going to go the other direction, minus 38 by 38. Enter. And that's that plane there. So let's look at it from this. But now I want to draw on this plane, so I'm going to left click on it and then select create sketch. I'm going to pick my circle tool. I could align it with that one, and I want this one to be 4.0597. Okay, enter. Right click and OK. It's fully constrained. That's good. So we finished sketch. Now all we need to do is to create a loft. So I'm going to click on my loft tool. I'm going to create a loft between that shape and this shape, and there we go. I'm happy, and that's it. Okay, so we can now toggle off visibilities of these planes. Great. Now, but each of these guys have crowns, okay? And from the data sheet, the diameter or the radius of the crown is 4.6482. That means the diameter is 2 times that. So I'm going to look for the plane that cuts this midway. I will go with the YZ plane. I'm going to right click and make it visible. Then I'm going to left click on it and click on create sketch. I'm dealing with so I'm going to select slice graphics so I can see that. Come in a little bit here. I will project that line so it's easy for me to reference it. But I pick the center point circle to click and drag out. This diameter is going to be 4.6482. 6.82 times 2, because that's the radius, right? Times 2, and that gives me the diameter that I'm looking for. Okay, I'm going to just come back down here and do the same thing. Click and drag out. It is going to be 4.6482, and I'm multiplying that by 2. Okay, enter. That's the diameter. Okay, I'm going to pick my project geometry and also project this line. Now I'm going to pick my coincident constraint, and I want the end of this line, okay, the point to be coincident with the circumference of that circle. And the same thing here, the end of this line to be coincident with the circumference of this circle. That gives us the crown that we need. And then here also, I want the end of that line to be coincident with the circumference of that circle, the end of this line to be coincident with that. Okay, what is left will be to draw the axis where these two guys are rotating about. So I pick that, and I'm going to draw from here all the way down. Let's make it 50 millimeters and click on enter. Right click and OK. Now select that line, go to the format panel, make it a center line. Okay, now I need to trim off everything that, so let's delete that diameter. Let's delete this diameter. So I'm going to pick the trim tool. All I want is this to go away, this to go away, right? This should also go. Aha, see, I've not drawn the line, so it would not have rotated. I need the line from there to here. Okay, cool. Here also I need a line from there to here. Right click and OK. Okay, where is my trim tool? Pick my trim tool, I trim that off, I trim this off, I trim this off. Okay, great. Right click, OK. 4 dimensions are needed. Kindly help me apply them. Automatically apply dimensions and constraints done. Fully constrained, I finish my sketch. Now I pick my revolve tool. There are 2 profiles. I'm going to select that profile, right? And this profile, where is it? Oh, did I not draw a line? So because I did not draw a line, it is not selecting that profile. Okay, let me go back and edit that sketch. Right click, edit sketch. Okay, I thought I drew a line from that point to this point, right to that point. Right click and okay, let's finish sketch. Finish sketch. Have I finished? Yeah. Let's pick the revolve tool. Select that to revolve and select this also. Great. And what's the axis? That's the axis. So there you go. You have the bottom ends of the something automatically selected. That's what I'm looking for. So I'm going to press OK. I'm going to hide this view. And I'm going to select galvanized stainless steel so that it will shine. There we go. And that's my tipper pin with the crowns at the end. Let's save this. Just save this as the number 2 tipper pin. Okay, enter. So with this, we have created all the components that we need. Now I'm going to take a pause, drink some water, and then come back, and we will now create the working drawings for each of these guys before we assemble them. Okay, so let me get to my OBS. All right, thank you for waiting. Well, you wouldn't wait at your end. Okay, so we will go into creating working drawings for these. So I'm going to start a new file, Control N, right? And this time around, I'm looking at a standard ANSI drawing file. You can either use ANSI, you can use BSI. All of these are .idw files, right? But they are according to different standards. Okay, there's the ISO drawing file, there's the ANSI drawing file. Maybe I should use the ISO drawing file so you have a look. So let's use the ISO. ISO is the international standard. So select that. Okay. These are the templates. I can use that template. I can decide to use this is A2, this is A2, this is A4, but so I'm going to use that one and create. Okay, so it's going to come up shortly. Great. So in this workspace, you see that there is a sheet of paper. Okay, that you have your border line so usually when you do manual drawing, when you get your drawing sheet, the first thing you do is to draw the border line, right? This already has that with you, and then you have the title block. Okay, now, but you can change the properties of this sheet. Again, it has the same quick access toolbar, title bar, help bar, then it has tabs. But note the tabs. We have place views, we have annotate, we have sketch, we have tools, manage, and the rest. Okay. We will basically use place views and annotate. Place views is where you bring in an already created model and then you create the working drawing. Working drawings are usually in orthographic projection, either third angle projection or first angle projection. Okay. In first angle projection, your front view is placed. That's the figure. That's the shape that you're going to be referring to. The plan is placed beneath the front view. Then the right side of your drawing of your model is placed on the left side of the sheet or of the front view. That's first angle projection. In third angle projection, the plan is placed on top of the front view, and the right side view is placed on the right side. So you have the liberty of placing the views in whichever way you want to place them. Okay. So if we ask you to describe how to do something in third angle projection or in first angle projection, you need to know where to place what. Okay. So place views is where you bring in your models, and then you have you can create various perspectives. You can create section views, auxiliary views. You can do detailed views, and so on and so forth. You can break out. You can, if there's something that's extremely long, you can break it to shorten it, and so on and so forth. Okay. So that's that. Now in the model browser, you have the drawing. This is the drawing. You have drawing resources, which includes the sheet, the borders, the title blocks, and then sketch symbols, right? Now I have one sheet. You can add more sheets by right-clicking and saying right-clicking on the drawing and clicking on new sheet. Okay, we will have a few more shortly. Now, if sheet 1 here, I can right-click it and edit sheet. Okay, your edit sheet dialog box is going to come up. You can edit the name of the sheet. You can change the size. So currently, this is on A3. Okay, but I want it to be A4. So I select that, change it to A4. You can change the orientation from landscape to portrait, but landscape is what we usually do. Okay, so you see that the sheet size has changed. This is A4 now. Now I can print this out. So when you're doing your drawings for your final year projects, make sure that your sheet is an A4. You might want to choose a default sheet that is A3 or A2, very large, like your drawing sheet. And then when you place your models on and you're printing, you'll be struggling with the printing because the size of the sheet is different from. Okay. Again, I can delete this border and insert. If I want my own border, I can insert my own border. I can create. Okay, I can define a new border. Same thing with the title block. Okay, I can insert the ISO title block, or I can define my own. Now I'm happy with what I have, so I'm just going to close down my drawing resources. Now I'm going to bring in the models. I will first start with the pin. So I'm going to go to the base view. That's the view I want to place. I'm going to click on that. A dialog box is going to open up for me to select what I want to place. So I'm going to click on the browser icon there, and I'm an inventor. No, that's not the folder I want to be in. Excuse me. I'm going to go to Justum, courses, CAD and CAM, and where is my video exercise? Now this is where I've put all the stuff I've done. So I'm choosing the pin. That's the guy. So I'm choosing that guy. Now, okay. I've chosen it. Now look at the scale. The scale is 1:1. I look at my paper. Yes, 1:1 fits. I can do this 1:1. Now this pin, that's my front view, right? Let me move it this way. Now, when I move my cursor in a given direction, you see some dotted lines. It creates a view that way. If I move it down, it creates a view down. If I move it this way, it creates a view there. Let me show you what I mean. If I go up there and I click, you see that view created, right? As looking at this thing from down that way. If I come here, it drops, right? As looking at it in that view. If I come this way, it drops that. If I come this way, it drops it. All right. So this is in first angle projection, really, because what you see up there is what is here. What you see down here is what is there. So the inventor creates these drawings in first angle projection. Now, if I want to create an isometric view, instead of moving horizontally or vertically, I move diagonally. So if I move diagonally, right, I place that. You can see that view. Maybe I want that one, or I want this one, or maybe I want. So you can place your stuff diagonally. Now I'm happy. The scale is 1:1. Okay. All right. Now of all of these, I like this one the most. Now you can move the isometric views independent of these ones. Okay. I don't know whether I should use this or this. Well, I'm going to delete these views. I don't want that one. I'm going to delete it. Delete view 6. Yes. You know, when you hover over it, you will see that dotted line about it that says that's the view you're dealing with, right? So I'm going to select that and delete view 5. Yes, I want to delete that. I like this view. I'm going to keep that one. I'm going to select this view and delete it. Yes. Okay. Now, I'm contemplating whether to keep this view or this. There's no point having both of them. So I can move it that way and then move this isometric view here. Okay. Now, remember the isometric view is independent of that. This is with hidden details and raster lines, okay? No solid, but I want this one to look like a solid shape. So I'm going to right click and edit that view. I have options in the style. There's the one with hidden lines, there's hidden lines removed, and there's shaded. What I want is the shaded. Did I select it? I want the shaded, so I okay that. So it provides, sorry about the noise of the door opening. So it provides for me an almost realistic shading of what that component looks like. Let me bring this back a little bit. Now, out of these two, I think I will keep the one at the bottom. So let me delete this view. I'm going to take this up that way, bring this way, so that we can dimension. I will not, for want of time, do this for every component, okay? I'll just do this for this, and then you can do the rest. Now, here we go. For dimensioning, you need to go to annotate, okay? Now, in annotating, the first thing I usually do is to find, for circles, to find the center marks. So I'm going to find the center mark for that circle. I'm going to find the center mark for this circle, and I think it provides for all the rest. Then I'm going to use a center line bisector to show that this is not just a square. Because if the isometric view is not here, whoever picks this should know that it's a circle by it having a center line bisector like that. That's when we know that that's a circle. And same thing for this. So we do it through all of them. Same thing for that. Okay, sorry, I can't do that. Center line bisector for this and this. Yeah. So that's what we want. We do the same thing here. You have to click both lines so that it locates the center line. Okay. There we go. All right. So having put that, we now use the dimension tool to dimension. Okay. So this length. Okay. Select. What's the style? We can edit. This. Okay. I was waiting for that. Precision. I want it to be 0, so to an integer whole number. The text, the size is okay for me. Precision and tolerance, that's fine. I'm happy with that. I'm going to OK. Now do note that is using comma for decimal. So I'm going to change that. If you go to manage styles editor, you click on styles editor. It's taking some time. A dialog box should come up with a number of options for me to work on. Where are we? Hope this is not becoming too slow for me now. Yep, it's processing. I hope this does not. Okay, there we go. Excuse me. So this is the styles editor, right? And I want to look at the dimension, right? Drop down is using this. So the decimal marker is using comma. I want a period for that. Okay. I want a save to that. I want a period for this also. Right. Oh, my system is slowing down. The video is becoming quite long and the system resources are becoming low. So I'm running both OBS and this. I think it's the first default method 1B that we're using. Let's see. Oh, let's see that. So I want period. Yeah. Save that. This I want a period. Okay. And I'm happy. Save and close. So now let's go back to annotate. Pick my dimension tool. And I'm going to pick this length, right? This is 31.5. Still using the comma. Did I not save that? Am I using a different? Anyway, I don't have time for that now, really. No, I do actually. I need to change that style. Manage styles editor. So basically, while that is coming up, you see that all you are doing, Inventor would retrieve the dimensions that you've used in building this. So you are not going to be writing it yourself. However, you can override. Okay, in the annotate, there is a place for overriding. You can override. A given dimension. Okay. The default one I said should be period, isn't it? Save. Yeah, that's period. Let's make everything period. Save. Period. I'm happy. Save and close. So let's see now. Let's go to annotate. Pick the dimensions. Now, I do not just want this length. I want the whole length to the bottom. So I'm going to zoom in a bit, right? And I'm saying that length to this length, right? 33. Now it's doing point, which is what I want, right? So I'm going to click on that. It's going to bring up the options for me. I do not want the decimal, so I'm going to change the primary unit to an integer that way. Okay. So that dimensions, here we go. This to this is a diameter. So there it shows you that that's diameter. And I click on that. I'm going to click 0 and OK. This one we will do it down here. Okay, diameter 12. We will also change this to 0. Now the beauty with this is you have a liberty. You can also place some of those diameters on this, right? Okay. Now I'm going to do that. That one is diameter 40. Okay. It's diameter 40. Okay. This hole. Well, I even forgot to put the bisector here between that and this. Yeah. There is this thing for holes and threads, a tool to label holes and threads properly. So I'm going to select it. Oh, it's not recognizing this as a hole. It should. No, it's not. Fine. So I cannot use that here. It's the other one. Maybe I'll just do that so that you see. So this is of radius. Was it 2.2? Oh yeah, because remember it's tapering. That's why. So funny thing, watch what's going to happen here. Let's escape that. Let's pick the dimension. Let's see what this will be. Okay, you see this radius here. Oh no, that's something else altogether. That's something else. Well, I'm going to leave that because of my time. So I'm going to select the distance from there to here, 9. Precision, all of this. Okay. And so on and so forth. So you get the gist. You will know what to do. This here, the radius is 22. Okay. Radius is 22. 0. Okay. I could have even selected it from there automatically, not to have any decimals instead of going back and forth. Now I can move some of these around so that is outside. Okay, I preferred something like this. Okay, then I can move this back a bit, move it down, move it here. Good. So there are so many options, but notice that in moving that around, the dimension tool is not highlighted. If you do that, you run into trouble. The chamfer, you can label chamfers. I can label that, but that's getting busy, so I'm going to label this chamfer here. Okay, just click on it, and it should give me the information. What's going on? Okay, I needed to select the two of them for it to give me that. So it's 1.5 like that. So you remember that it draws out that information by itself. This one I can't change the decimal because it's going to affect the 1.5. If I remove the decimals, that becomes okay. So here we go. I've dropped the image of the pin. I think I've put down all the necessary dimensions that were used in creating it. Okay. The title block, you can feel the title block here by, if you right click on the pin, you go to eye properties, you click eye properties, you can put what's the title of this file. Let's see the summary. What's the title of this work? EME 508 video exercise, right? Who is the author? Engineer Dr. Fado Unom, right? Who is my manager? Engineer Professor MK Yambase. Who is the company? just to, right? So all these details we come depending on the ones that are there. Now let's look at the project itself. Do we have a part number we can put? Do you have a stock number? So if this is a different, a huge assembly, you have part numbers for each of these. If they're already in the market, they will have stock numbers. You can describe them, revision. If this is a second iteration of it and all of that, you put all of it there. But what's the project? Again, we're dealing with EMA 508 video exercises. Who is the designer? Engineer Dr. Fado G. Uno. Okay. Who is the engineer that's going to make it? Let's assume Engineer Festus Olorun Shogo, if I got that correctly. Authority, where's the money going to come from? It's going to come from Justin. Do we have a cost center? If there is, we will say mechanical department finances, right? How much will the estimated of this spin cost? You can put all the costs there. When was it created? All of that. Okay. So once we apply, just watch what was going to happen here. This is going to be populated. Apply. Okay. So Control D. You see that it fills in the title block by you filling in your this. So status, who checked it? Engineer Professor K. Gambison. Okay. Who is the engineer that approved it? Same. Okay. Same. He approved it. Who is manufacturing it and when, you can put all the dates and all of that. Okay. And apply. Okay. Now it looks like the names are becoming longer than this. This is where you can come here and change your title block so that it has certain settings. But if I want, I can just well, I don't have time to do all of those now, but you have an idea of where to fill the title block. Now, to show you how to use holes very quickly, the time I set for this has finished. I'm going to create a new sheet. Okay, this is the second sheet. It has the same properties as I had before. Now, place views. I'm bringing in this time around. I want to bring in the bracket. Okay, open that. The scale. Okay, so it's halved it because it's quite big. What if I do 2/3? That should be bigger. Yeah, that's bigger. 2/3 of that. So, oh dear me. What I want to do is move this here, put that there, and then look at that. I don't want that view. I don't want this view. I don't want that view. That's the view that I want, right? Everything is going to be, is going to be hidden lines shown. So I'm going to OK that. Like I said, I do not want this view. Yes, I'm going to delete that. I do not want this view. Yes, I'm going to delete that. I do not want this view. Yes, but this is the view that I want. So I'm going to bring it there. I'm going to right click and edit the view and make it solid. Okay. There we go. So you can do dimensions here the same way we did before. I'm not going to do too far, but I just want to look at the hole. Okay, so look at how it's able to dimension that hole using holes and thread. It tells me that hole is 12 millimeters and it goes all the way through. Okay, I can put my center line on that, center line on this as well, right? What again? Here too. Okay. Oh, in fact, there's a view that I've missed. So now that there's a view that I've missed, see how you correct this. I'm going to drop that center line. I'm going to move this a little bit. And then I'm going to go back to place views. I'm going to project this view in this direction. Okay, because we needed to see those holes. Right click and create. So there we go. There we have that hole. I think I can move this a little bit this way so that I can shift this like this, right? So here you can still go to annotate. Let's put the center line on these guys, these two guys here. Where's the bisector, so that we know that that guy there is that. Same thing here, we have, if you want that and this, great, and this and this. All right, now we can use the whole tool and select this guy like so. Right click and okay. Now I'm going to edit this, double click. Okay, when it comes up, it goes me that, and I will say times. Does it have a times for me symbol here? Do I have a times? Do I have a times? No, I don't. So I'm just going to use X times 2. Okay, to show that there are 2 of those holes. Okay, let's check the precision and tolerance. I don't want those decimals. Hey, I thought I clicked on something. Oh, it came and went. Sorry, I'm being impatient. Okay, there we go. It's using the global precision. Let's use path tolerance. Leave the global. Change this to 0. Change that to 0. Change this to 0. Okay, that's the depth. Yeah, I want it to be 0. Okay, that's what I want. Okay, that's what I want. And there we go. Okay, so you see how I've been able to label that hole. You can do the same for all the other stuff. Okay, if I'm having this, I can say R25 what's the unit, 0, what's the text here, I can say times 2. Okay, and then it appears there, knowing that it's there. And that I actually do need some. Do I? No, I shouldn't do that. That will make it more clumsy. So this is how you create these working drawings in the views that you know is required for you to produce them. All right, that's drawing. Now, very quickly, in the next 10 minutes, I'm going to assemble this thing together. Okay, so we have certain sheets. You can move from sheet to sheet by double clicking. If I double click on that sheet, it brings me back to sheet 1. So this was the guy we had in sheet 1. Let's go back to sheet 2. Double click, come back to sheet 2. Okay, and this is what you can print and put in your projects and the rest. Excellent. Let's save this. Let's save this. We're saving this as the drawing files. Okay, great. Now Control N to start a new file. Very quickly because of my time. I'm going to do a standard assembly file in millimeters. Okay, so I'm going to create that. It brings me into the assembly environment. Okay, now good. Again, you have its own tabs. You can, from the assembly environment, draw all your models. So you start from the assembly environment and keep drawing them. But obviously, we won't have time to deal with those. That's why you still see some of these guys here. But the beauty of the assembly environment is after you've assembled, this is when you are able to put in designs. Okay, I thought we'll get to this. You can do frameworks. You can create a schematic and turn it into a framework. You can put bolts to bolt sections together. You can insert shafts. You can insert gears. You can put bearings, and to do all the calculations that we've learned how to do from 400 level to now. This does it for you, free, like in no time. You're able to see the performance of various things, right? But in addition to that, is also able to simulate. Okay, this takes you to let's go to environments. You are able to simulate, where you can do dynamic simulation. You find out natural frequencies. Sorry about the noise. So you find out the natural frequencies of the model, or you can do static analysis, okay, or you can do a simplified frame analysis where a lot of the parameters that will make this bulky are reduced in this case, and then you are able to run and see how your model will behave in real life. Okay, and there are a lot of other things. How about if I'm dealing with cape and harnesses? How about tubes and pipes? How do you do tolerance analysis? How do you convert parts to weldments to show that they are welded? And then how do you prepare it for 3D printing? If you created a model that you're going to 3D print, all of that you find in the environment tab of the assembly file. But for today, we're just going to assemble. Okay, so you can, okay, this is already in place from Content Center. You can, maybe as an example, if I click on this, it opens up a Content Center, and that's why I usually insist that you download it from, you download your Inventor from Autodesk Inventor directly, Autodesk directly, right, instead of all the cracks that you guys use around. First of all, it's against the law, it's unrighteousness. Anyway, so here you have different fasteners. So we want to insert, there's a Content Center, there are different fasteners. There are bolts. If I click on bolts, you see all the different kinds of bolts, the countersunk head, the hexagonal head, the hex head, all of that, right? You have nuts, you have pins, you have rivets, you have washers. Let's even see whether they had the taper. There are taper pins. So in fact, what we're trying to draw, we could have just come and inserted. Let's see whether it will have the number 2 taper pin. Let's select this. If we select that, it's going to bring a pin for us to insert, and then we will choose from the data sheet which pin. Okay, now you see, let's look at the table view. There is a number, I don't know whether this number 2 is the one. A is 0.6 pi. But here you see all the, I thought it should have labeled it part number. No, that's not what I'm looking for. Anyway, what was the length? Nominal length. Nominal length. So if you come down, there's different stuff with different lengths. Well, I haven't seen the one that is 38. 34.4. Okay, the closest is 39.2. Okay. Oh, nominal length. Anyway, you get the gist. Let's assume I pick that and I say, okay, let's look at the pin that will be brought in the 3D environment. Click it there, and there we go. Okay. So here you find the pin that I brought in. What we're struggling to draw, you can always insert from Content Center. All right, so the Content Center is where you can insert parts of your assemblies that are standardized products, okay, that are in the market, from fasteners, right, which includes bolts, nuts, pins, different kinds of pins, groove pins, cylindrical pins, to rivets, to washers, okay, to shaft parts, to tube and pipe fittings, okay. You can do all of those. So that's the Content Center. So you place all of those from Content Center. But I do not want to place from Content Center. I'm going to delete this guy. It's not part of what I want. So if I drop down here, I can place components. Where's my place? Oh, that's what I'm looking for. Place. Okay. Place. Where am I going to place this from? Let me go to courses, CAD and CAM, exam, video exercises, right? You can select all of them and bring in at once, or you can bring them in one by one. The advantage of bringing them in one by one is if they are orientated differently, you can change their orientation to fit what you're looking for. Let's start with the bracket. So I pick the bracket, it gives me the preview. That's what I need to bring in. So I'm going to open that, right? And this is the way it is looking. Now, if so let me go back to home. Aha, good, very good. If, however, follow me, if, however, this bracket is not orientated correctly, okay, you can rotate it about the various axes until it's at the orientation that you want. For example, if you look at the cursor, right? Let me zoom in a bit. You see that Y is pointing upwards, X is pointing to my right, and Z is pointing to my left. Okay. Now, I could right click and rotate about Y by 90, rotate about Z by 90, rotate about X by 90. Now, when I rotate about Y by 90, watch what happens. The orientation has changed. It's now facing that way. What if I rotate about Z by 90? Okay, so you are able to change the rotation of your object, or the orientation of the object by using those features. I'm going to take it back. I'm going to rotate again and rotate again and rotate again. Take it back to where it was. Then I rotate about Y, rotate about Y, oh, rotate about Y, rotate about Y. That's how it was before. So I'm going to just drop one instance of that. You can drop as many instances as you keep left clicking, right? You drop as many, but this case I need just one. So I'm going to OK. Now I bring in the next one. I click on place. The place component dialog box opens up. Now let me place the wheel. I'm going to bring in the wheel. Open. The wheel should be somewhere there. Just one instance of it, and I'm happy. Okay. Let's bring in the the bushing, right? Bushing is next. Open up. Okay, just one instance of it. Okay, what's next? The pin, right? Open. Can place that up there. Okay. I think Control P or just P. Something should open up. Okay, yeah. Once you press P, P opens up the place component dialog box. So instead of going there, once you press P on your keyboard, it opens it up. What's left? The taper pin, right? So choose the taper pin. Open. Now everything seems to have been orientated correctly. There's that. Okay. Now when you look at this thing in the isometric view, it could be very deceiving to know whether they are properly arranged or not. So sometimes I like to go to the front, okay, and then that helps me to align if I want things to be aligned properly, right? Give it more space because when we start assembling, okay, and then I can move this pin somewhere here, right? Now this is on this side. So let's flip to the right side and see how they're oriented. Again, you see, so this can be moved here. This can be moved here. That's only when you know that these things are directly above themselves. I can move this to the side. Okay, so let's go back home. And there we go. Now, in assembling, what you're basically doing is you are defining the relationships between the components. Okay. So in relationships, there are two major things. There are joints and there are constraints. Okay. When you click on the joint tool, the place joint dialog box comes up. Now, there are different kinds of joints. If I drop them down, there are about 6 or 7. There's automatic joint, there's a rigid joint. A rigid joint means that those two joints happen between points. That those 2 points are held solidly. They are not going to move. Rotational means that one aspect, usually you might find it in cylindrical components. One aspect rotates about another. Slider joint means one goes in and out of the other. Cylindrical is also like sliding, but it moves the whole stuff. Not only rotates, but it moves up and down as well. Planar means one component is permitted to move on top of the other. And then ball is like ball and socket joints, right? So there are different joints that we use for different things to define the relationship between these things. And then there are constraints. Constraints deal with lines and faces, okay? And the first type is the mate constraint, where you can either mate or flush. So you are saying this surface and this surface should be mated. That means they lie on each other, right? and whatever you do, you can't separate them. They can move relative to each other, but ideally they are all touching the same infinite plane. Okay, when you flush, instead of lying against each other, you make them level, that their planes are level, so one cannot go above the other and vice versa. You can move them in any direction in this plane, but they will flush. Okay, that's what that is. And then you have the angle that defines the angle between two given faces or lines. And then you have the tangent, okay, and you have the inside tangent and outside tangent, okay. Then you have the insert. You want one thing to be inserted into another, and this is particularly with cylindrical components. And then you have the symmetry, where you create a symmetry between stuff. Now, these are the things that we will use to do this. So first, let's start with the bracket. So I'm going to fix this bracket. I'm going to right click the bracket and ground it. Okay, that means that you can't move. So watch, I can move this guy, right? But I can't move him again. I've grounded him. He can't move anywhere. I've said where it is, fix it there. So that becomes the reference point where every other thing can be referenced. Okay, so let me move this away. Now, what I'm going to do, we know, follow me carefully, that this pin here enters here. The way I've designed it is such that this bottom here of this part is going to sit on this face. So I'm going to use my mate to do that. So I'm going to go to constraint in the relationships tab, and I'm going to select mate. Okay, then I select that face. Now I'm going to take off the highlight so you can see what's happening. Now you see that red arrow pointing downwards. That face is going to sit down on something, right? Because of its orientation. So I'm selecting that face, and I change this, and I say I want that face to sit on this. Okay, you always hear that noise when it brings things together. All right, now I would have applied and done another, but I'm going to success. I'm going to okay that. I can still move this around, but let's look at the front now. Let's turn to the front and see. The only movement I can do is back. Is that I can't take this thing higher. I'm trying to drag it up. No, I've created a constraint. I've said that face must always lie on the same plane as this face. So the only liberty it has is to move here and there. Okay. Now, I'm going to now fit because it is a wheel. So this will be okay. There's going to be a taper pin that will hold that in there. That's fine. Let's allow it to be rotational and see. So what I'm going to do, I will do a joint, okay, and I will select this. Now, once you hover over this, you have seen three different points where you can create a joint, right? If I press my control, then I can jump between those points, control on your keyboard. Otherwise, if you don't, as you move, it might change and go somewhere else. But the joint I want to create is that top, because this is the one flushing. I don't know where the midpoint really is, because this is not the same with that. So I want that point. So I'm going to select that particular point. Then I'm going to come this way now and select also that top point. Okay, that's where I want it to be. And you see it has selected cylindrical. You see the animation to show you how the cylindrical move, but that's not what I want. I would rather that it be rotational. So you see it turning, right? That's what it can do. It can turn. But I think ideally, it should not actually be rotational because, well, let it be. Remember that there's a pin, there's a hole there, right? Now we're going to align those this guy in. Okay. So what am I going to do? I'm going to choose insert. Okay. I'm going to choose insert. So I'm happy with that relationship there, but I'm going to pick constraint. I'm going to pick insert, right? And I'm going to pick Let me turn it this way. I'm picking that taper pin, and I want to insert it where? I wanted to get to. Have I highlighted it properly? Did I get it? Before I put that joint, I should have inserted because it becomes okay. Let me, to aid me, I am going to hide. Let me cancel this first. I'm going to hide the bracket. Where is the visibility? I'm going to hide the bracket so that I can see this fully. So now I can come here now and select constraint, insert that where. Oh no, you're not giving me the correct thing. All right, let me see whether I can do something else. How about mate? Mate only works with flat surfaces. Oh, I can mate that. Oh, great. So it's done what I wanted to do. So you can change the offset, but I think I want it bang on in the middle. Let's see. Yes, I want it back. So how did I do that again? So that you say, sir, what did you do? Let's bring it back out. Okay. So constraint mate, right? Mate. I want this guy to be mated about that. So once I do that, so you see the direction, that and this, automatically this comes up, right? But it's not centralized the way I wanted it to be. So I click on this. Opposed. No, I don't want opposed. Aligned. I'm going to do that again. Cancel. You have to be careful what you do. So I'm picking that point, right? And I want it to fit inside. Okay. Now you see that symmetry that showed. The arrow is where it's going to be aligned. That is not where I want that guy to be put. So this guy and that's the correct arrow. That's the correct arrow. Good. Now let's look right and see. Okay. I want this guy to be symmetrical. Okay, to be somewhere in the middle. The offset here is 0. This is aligned. That's what I'm doing. This is unidirectional. No, that's not what I want. The aligned. But offset by what amount? The stuff was 38. Let's see. Set. Oh no! So it's bringing it back and out. No way. That's not what I. Now let me turn this way so you see what I'm saying. He moved it out of that by 30. I do not want that offset. I want it to be bang on in the middle there. What I want to do is to move it along this length, right? Okay, limits. That's what I want. Sorry, I'm not finding what I need to move this guy for now. So I will just let it be. Transitional. Nope. This guy. Okay, there we go. I wanted him to be somewhere. In the middle. Fine, that's fine. I'm going to move it out a bit. And I'm mating. Cancel. Sorry, I'm going to do this one more time because of my time. This and that. Apply. I'm happy with where you are. I'm going to make this visible back so I can see that. Now, what I will do is constrain. I want to mate that with this. No, that's not what I want. I can use joints. I can use joint. So join rigid, that one with with that one. That is exactly what I want. Okay, so you see that it just starts at the beginning here, and if we come to this side, move that up a bit, you can see that it just ends there. That's exactly what we want. Great. So that's that. Now it says a relationship cannot be. Let's diagnose and see. Connected taper 2 pin is having problems with taper 2 pin. What's the problem? The rigid stuff I created. The mating. So where is the problem? Suppress broken, delete broken relationships. Which one is broken? Check. The current constraint has been resolved. Would you like to? Yeah. Okay. So since it's resolved it, I actually don't even know what the problem was. But here we go. That's the pin, right? But inside this pin is supposed to be this. So let's get the bushing. Let's fix the bushing there. So I will. Should I do a joint? Yes, I will select the joint, and I want a bushing allows for this to rotate about that. So two things with bushings. Either the bushing is strongly fitted to the wheel, so this outer diameter is fitted to this one such that the bushing does not move relative to the wheel, but the inner hole is allowed to rotate about the pin. That's one way. Or the inner hole is fitted strongly to this, and then the wheel is allowed to rotate freely about the bushing. I think it's usually the first case. So I'm going to choose a rotational behavior, okay, and I will select the inner. I'm looking for that. So I'm pressing Control and I'm taking that midpoint. Should I have used the midpoint? Well, let's see, and I'm going to take it to the midpoint there. So it goes there and it's going to be free to rotate about that. I'm going to apply, and then just leave me alone. I'm going to choose rigid now, and I'm going to choose the middle of that, and I am going to fix it to the middle of that outer one there. Okay, so there we go. When you see that there is a gap. Okay, there is a gap between this, and it's deliberate so that as the wheel rotates, it is not creating friction with that. Okay, because of the way the pin holds that. I don't know whether the bushing would eventually fall and sit on this, but that's the arrangement. Now, if we look at this, if I had an irregularity, you would have seen that this wheel can rotate. As I'm holding it, it's rotating, but you will not notice because it's completely spherical. But what if let's look at what the inside looks like. View, let's do a half section view, and I want that to be on this, okay, so that we can see okay, keep coming. So this is fine. Okay, so you can easily see how these things fit, right? The pin goes inside this, okay, inside the bracket, and then the bushing is there fitted to that portion of the pin, and then the wheel is fitted to that. You can see the section parts of it. Okay. All right. So For want of time, I'm going to stop there and upload this video. I wish you all the best in your exams. If there's anything I have not mentioned and you see in your exams, well, that would come out to you as a bonus. But if not, you have all that it takes to answer all the questions in the exams. All right, God bless you, and I'll see you another time. Thank you.